How are you doing? Hope you all are fine. Okay. So welcome to Ekeeda, and today we are going to solve a problem based on unsymmetrical bending. Unsymmetrical bending. Unsymmetrical. Okay. Symmetrical bending we know. So what could be the unsymmetrical bending? So and how it happens? What is the reason behind unsymmetrical bending? Okay, as the word resembles, it's not symmetrical, right? It's unsymmetrical. So there are two things. Okay, when unsymmetrical bending can occur. So once when the section is symmetrical and when the section is unsymmetrical. So for both the cases unsymmetrical bending happens. Okay, so here let me show you this one example of a symmetrical section. So this is a beam. You can see this is a beam. Now in this beam, this is a symmetrical. If you cut it, so it's a rectangular, right? Rectangular cross section. Now here load is acting along this particular axis. Okay, straight line in y direction load is acting. So it will create a symmetrical bending. So it's a symmetrical section and same loading. So it will cause symmetrical bending. Now for this symmetrical section, it there will be unsymmetrical bending. Okay, for symmetrical section, for a simple rectangular section, it can have unsymmetrical bending when a load is acting in some angle. Okay, so it's not in the y direction. If you can see, it is in some angle. So when such load is acting, then it creates a unsymmetrical bending. So this is one reason. Unsymmetrical bending, I said only one reason. What is happening here? It's a symmetrical section and angle, the load is inclined. Okay, load is inclined. The load is inclined to both principal axes. Now let's see other example, that where the section is unsymmetrical. So here for this particular, now these are the symmetrical circle and rectangular. This is symmetrical section, even I section, it is a symmetrical section. But this particular angle section, channel section, so for these particular cases, whenever there is a channel section, in this case, okay, when load acts on any one of the direction of x or y axis, okay, so in this case, when load is acting along any centroidal axis, then also it can create a unsymmetrical bending. Sorry. So I told you two reasons when unsymmetrical bending happen. Okay, one is when section is symmetrical, when section is unsymmetrical. Okay, so to know more about it, to know the concept behind it, the theory behind unsymmetrical bending, kindly subscribe to Ekeeda. You may just visit Ekeeda and see the lectures over there. So this is our practicing lecture. Okay, we are practicing problem. So we are going to solve, take one numerical and solve it. So let me take you to numerical. Okay, so let's take the question. Hi, so Satish Mohite is there, engineer Satish Mohite. Hello sir. So this is let's take a question. So we are taking the angle section. Consider an unequal angle of dimension 100 millimeter by 100 millimeter, 100 millimeter by 60 millimeter, and 10 millimeter thick. So we have to determine position of principal axis, principal axis and magnitude of the principal moments of inertia. Magnitude of the principal moment of inertia. For the given angle. So please draw this diagram. So the channel section, how it looks like. So let me just draw it. So this is 100. And this side is 60. And the thickness given is constant throughout, that is 10 mm. So this is also 10 mm and this is also 10 mm. This side also 10 mm. So these are the details given. So 10 mm by 10 mm thickness, and this is 100 and this is 60. Okay, now we have to find out what is the position of principal axis. So for that, what are the steps? Okay, there are some steps. How do we going to find it out? Anyway, position of principal axis means we have to find out first what is the centroid. Okay, where is the centroid lying? So x bar and y bar. So students, are you there? I need your help. Okay, I want you to do the calculation how we are going to find out the centroid of this particular section. Okay, so let's find out the location of centroid. Location of centroid. So first of all, let's divide this particular angle in two parts. So let's say this as 1. Let's say it as 1 and let's call it as 2. So write down the area, calculate area. Let's say area of first part A1, that is 60 into 10, 600 millimeter square. Area 2, what will be area 2? We have considered this part in 1 only. Okay, we have considered the 60 as a full part, so the remaining will be 90. Okay, we will consider this part only because 100 minus 10, that will be 90. So it will be 100 minus 10 into 10. So it will be 900 millimeter square. So area A1, A2. So we know the formula x bar equals to, what is x bar equals to and what is y bar? That's what we want to calculate, right? Centroid. We have to find location of centroid. So let's find out what is the location of centroid. Now let's consider the horizontal distance from the AB. Let's name it AB and AC. Let's consider the horizontal distance from AB and vertical distance from AC. Okay, so let's consider x bar from here and y bar will be from AC. Okay, from x bar from this AB and y bar from AC distance. So let's consider one point. Coordinates, let x1 y1 and x2 y2 be the coordinates be the coordinates of CG of rectangle 1 and 2. Rectangle 1 and 2. Now, what is x1 bar? So x1 is equal to, this is the area 1, right? AC, this is our element 1. So what will be the x1? This is 60. So x1 will be half of it, right? So 30 millimeter. So 60 by 2, 30 millimeter. That is x1. So we got x1. What is y1? So this is 10 millimeter. So 10 by 2, that is 5 millimeter. So this is x1 we are done with. Now x2, what is horizontal distance? This is 10, right? So half will be 10 by 2. This is 5 millimeter. And y2 will be, it is total 100. But 5 is going in that, here it is total 100, right? First how much we will consider? So we will consider first 90. 90 by 2 plus 10 we will consider. Okay, it is 90 by 2 plus 10. So it will be 45 plus 10. So 55 millimeter. So y2 means half of it. Okay, from here to here. And then we want that y distance from AC. That's why we have added 10 mm over here. So once you are done with x1, y1, then simply substitute in the formula and get the CG distance. So x bar is equal to, x bar is equal to a1 x1 plus a2 x2 by a1 plus a2, y bar equals to a1 y1 plus a2 y2 a1 plus a2. Now what is a1 x1? Substitute all the values and get the answer. So it's simply x bar is equal to, a1 is 600, x1 is 30. 600 into 30 plus 900 into 5. Divide by a1 plus a2. So what is the answer you are getting? Just check it. 600 into y1. What is y1? y1 is 5 and y2 is 55. Divide by 600 plus 900. So do the calculation. Tell me if you are getting x bar, y bar, what is the value you are getting. So when you do this calculation, so please see if your answer is matching with mine. My answer, I am getting it as 15 millimeter, and y bar I am getting it as 35 millimeter. Okay, so this is x bar, y bar. Now this centroid, okay, this centroid G is below line AC. This centroid, what distance we got? That we got it as 15 millimeter x bar and y bar is 35 millimeter. So just let's locate it. Locate the centroidal axis. X bar is 15 and y bar is 35. So x bar is 15, means this is 10. So 15 will be somewhere here and y bar is 35. So let's draw it. 30, y bar is 35 means Okay, so here this point is our where our centroid is lying. So here we'll show this 35. This is our 35 and our 15 millimeter. This is 35 millimeter and this is our X bar. This is our X bar. Okay, this is our Y bar. This is our X bar. This is Y bar 35. X bar is 15 millimeter. So our centroid is, let's show it as a point G. Okay, so centroidal point G is lying in this at this point. Okay, so once we are done with this, now let's name these lines as x-axis. Let's name them as x and let's call it as y axis. Okay, so we have, once we locate this x y axis, then x's and y are the these are the axes passing through centroid. Now we have to calculate what is the moment of inertia along this point. Okay, let's calculate the moment of inertia. So I'm taking the next page. So let's calculate moment of inertia about x-axis and then moment of inertia about y-axis. Moment of inertia about x-axis. I x x. So what is the formula for moment of inertia about x-axis? You remember? It's a BDQ by 12 plus A into h dash square, whereas h is a distance between x bar and actual that member. Okay, distance between that member. So first member is number 1. This is the first member. So what we will write? B d cube by 12. So this is B 60. This is 10. So B d cube by 12. So let's write down 60 into B d cube by 12 plus A into area. Means again we will write 60 into 10 and then we need the distance between the centroidal axis, that is y bar. Okay, y bar minus, we will write the middle distance between this distance. We need this distance, half of it. Okay, so y bar minus means we actually need this distance here. This distance we need. Okay, so what we will do? 35 minus 10 by 2. So we'll do the calculation if you are there and tell me what IXS value. Yeah, sorry, this is only for the one member. Then we have to consider the other member as well. So other member is, what is the B for other member? This is B. So 10 into 90. Okay, because first member is part of it. So the remaining length is 90. So B is 10. BD cube by 12. And then we have to see the distance, that is area, sorry. Then we will multiply 10 into 90 and then we have to see the CG distance here. Okay, the here the distance, let me just check the distance. This is 60. Yeah, this is 35. So we need, so when this is 35 means 100 minus 35. So we will show it as 65. Let me just mark the distance, then I will add it. So this distance, the bottom distance is 65. So now what we need, when we are considering second member, we need the distance. Okay, so middle of this particular member, so it is 90. So half of it will be at 45. Okay, so that distance will be at 45, means 65. This is 65 and we need this distance from here to here. So that will be So we need this distance. This distance we need. Okay. So we will write 65 minus 45. Yeah. So let me write down 90. 90 into 10 into 65 minus 45. Yeah, and this has to be a square. Okay, so please do the calculation and what answer you are getting. So this is 60 into 10 cube. So here, as per my notes, I am getting Ixx value as 1512500. Please verify if there are any calculation mistakes and you can correct me if I'm wrong somewhere. Okay, so this is what Ixx value I'm getting. Now similarly find out what is Iyy. Yeah, so now we have used a formula BD cube by 12. So here it is a opposite way formula, it is DB cube by 12. So please find out Iyy. So here 90 into 10 cube. So this member, let me show you, this is 90 D B cube by 12 plus area. Area is how much? 90 into 10 into distance between CG. Now in x direction. So it is x bar minus, this is 10, right? So half of it will be 5. So that distance will be 5 and the whole square plus again the other member. Here you have to see D. This is depth now and this is width. So DB cube by 12. So 10 into 60 cube by 12 into 10 into 60. This is the area into the CG distance here. How we have to consider? Now that member, top member is 60 millimeter. So 60 millimeter minus x bar. 60 millimeter. 60 half of it, okay, sorry, 60 by 2, that is 30 minus x bar, the whole square. So with this, when we substitute value for x bar, we have the answer for x bar. So Iyy, we are getting it as 412,500 millimeter raised to 4. Okay, so this is our answer for Iyy. Now we got the moment of inertia. So what all we got till now? We have done the calculation for x bar, y bar, Ixx, Iyy. So these all calculations are done. Now here what is happening as the sides of the rectangle 1 and 2. If you see the sides of the rectangle 1 and 2, they are parallel to x and y axis. Hence we need product of inertia for this. So formula for product of inertia. Product of inertia. Now what is the theory between this product of inertia? You can go back and refer the classes in Ekeeda channel. A1 H1 K1 plus A2 H2 K2 Now here, what are all these stuffs? What is A1, what is H1, what is K1? Let's see all of them, okay? So K1, K1 is, it is a horizontal distance of, it is a horizontal distance of CG of rectangle 1 from XX axis. Sorry, from YY axis. From YY axis. So what is the distance, horizontal distance of CG of rectangle 1 from axis YY? So how much is that distance? So that is How we will get that distance? So this is total 60 millimeter. Okay, from YY it is 60 millimeter. Now we need a distance from y-axis, horizontal distance of CG of rectangle. So what is the CG of rectangle? CG of rectangle will be at 30 millimeter because this is 60. So rectangle CG will be at 30 millimeter. 30 millimeter minus x bar when we'll do, because this is our y-axis, this is our x-axis. So we need this distance. So let's write down this distance. So that is 30 minus x bar. So 30 minus 15, 15 millimeter. That is H1. Now we need what is that is K1. So let's find out what is H1. So H1 is equal to, it is vertical distance of CG of rectangle 1 or member 1 from x axis. So that is how we will find out the distance, vertical distance of CG of rectangle 1 from x axis. So vertical distance means we have to consider y bar minus for rectangle 1. So if this is our rectangle, okay, so this is our y bar. We know already, we have calculated what is y bar. This is our y bar and this is our x bar. So H1, it is a vertical distance of CG of rectangle 1 from x axis. This is our x axis. This is our y axis. Okay. So that distance will be from x axis, means we have to see this distance. So y bar, we will consider y bar minus half of it. Okay. 10 by 2. This is 10 millimeter. So 10 by 2 will be 5. So we will, y bar is 35 as per our calculation. So 35 minus 5 is 30 millimeter. Okay, so hi Aritra. Daily YouTube classes I'm planning to keep. Currently, I have classes. I'm taking class now, and then I'll be taking class day after tomorrow. Okay, so I can take classes. So I'm planning to, because now exams are approaching. So I was planning to keep it. So, anyways, today and day after tomorrow I have a SA1 class, and tomorrow I'll be taking SA2 class, same time. Okay, so this is our H1, and then let's see what is K2. So what is K2? K2 is horizontal distance of CG, horizontal distance of CG. And for more information, you can subscribe to structural analysis 1 and 2 if you need. Okay, yeah. So there all lectures and all syllabus, full syllabus is covered. So this is our doubt class. So any specific doubt, if you want me to come online, take class, so I can take it. So you may suggest me any topic. So I may take, and there is again a revision class. I'll be coming online for that. So K2, it is a horizontal distance of center of gravity of rectangle 2 from YY. So remember that whenever K term is there, it is a horizontal distance of CG. Okay, K term is horizontal distance of CG from that particular member, and H is vertical distance of CG from x axis. Okay, K is a horizontal distance from y axis, H is a vertical distance from x axis. So that you remember. So now for K1 and K2, they are with respect to particular member. So there are two members here. This is member 1 and this is member 2. So here K2 is horizontal distance of CG of rectangle 2 from YY axis. Now here from YY axis, so we need this distance. Okay, so this distance x bar x bar. Okay, this distance is x bar. So this is exactly our K2. Okay, so x bar minus 5. So here it is 15. Our x bar value is 15. So 15 minus 5, that is 10 millimeter. And it is towards the left of YY. Okay. So this will be negative K2 because it is in the left side. So that is we have to consider it's on left side of YY axis So we have to consider negative. So that's why we'll write it as minus 10 millimeter. Now let's see H2 distance. So H2, like first here we have seen vertical distance. So this is also vertical distance of CG of rectangle 2 from X6. Vertical distance of CG of rectangle. So this is our rectangle. The rectangle 2, it starts from here, right? This part. So just for reference, I am showing you the first diagram. Actual diagram is this. Okay. So this is our rectangle 2. So here vertical distance of center of gravity of rectangle 2 from x axis means it is going down. Okay, this distance will be down. So again this answer also we have to consider it as negative. So let's see H2 how much we are getting. So this is vertical distance. Oh yes, it's my favorite topic, Aritra. Shear force and bending moment. Are you in third year or second year? Shear force and bending moment. Yes, I enjoy teaching. It's my favorite topic. So we can discuss. Okay. So vertical distance of center of gravity. Acha, you are in third year. Okay. Fine, no problem. I can take it because mostly second year students have this topic. That's why I asked you. I can take that topic. So you want shear force bending moment for simply supported beam and cantilever. That topic you are asking or anything else? Please let me know. So vertical distance of CG. H2 is vertical distance of CG of rectangle 2 from x axis. So this will be our 65 because below distance is 65. So 65 minus 45. Why it is 45? Because total member length is 90. So this is 20. Answer will be 20 and it will be minus 20 as it is negative. It is towards the downward side below x axis. That's why. Okay, so that is negative. So once we are done with all the terms, then simply substitute in this formula. Ixy is equal to 600 into 15. Please substitute. Simply I am just writing all the values into 30 plus 900 into minus 10 into minus 20. Okay, so do the calculation and just tell me how much answer you are getting. Okay, so according to my calculation, it is this is 22 lakh 70,000 plus 1 lakh 80,000. So this is 4 lakh 50,000 millimeter raised to 4. So this is our product of inertia. Okay. So once we do this calculation, then we will be finding out what is the position of principal axis. Now we have done all the background work. Okay. So once we are done with this calculation, then simply substitute in the formula and get the final answer. Okay. So we are approaching at the actual solution. So position of principal axis. Position of principal axis. So for principal axis, our formula, now you have to remember this formula. Tan 2 theta is equal to 2 ixy divided by iyy minus ixx. So it is 2 into 4,50,000 divided by 4,125,00 minus 1,512,500. So when you do this calculation, our answer is 0.818. Okay, so now here when you do tan 2 theta is coming as negative, tan 2 theta, so this is the negative value, means it will be in this negative angle, means it will be in second quadrant. Okay, so second quadrant, because the angle is showing as negative. So here the angle tan inverse, if you do here 2 theta, so 2 theta is tan inverse of minus 0.818. So this will give us minus 39.28 degree. Means minus means do it as 180 minus 39.28. So actual angle is 140.72. So this is 2 theta, right? So theta will be half of it. So it is 70.36 degree. So this is our answer. Now the actual axis. Okay, sure, Aritra. I will take that class and I'll soon keep it. Maybe I think 4 o'clock is sounds good time. So maybe I'll just see to it that I'll come online. I'll try to come online most of the time. Okay. If this time is even suits you, so I can come online at this time, or later becomes little difficult. So maybe 4 is better. I think 4 or 3 is good. Okay. So I'll come. I'll take that class. Okay, so here theta we got it as 70.36. Now finally we have to show that unsymmetrical bending. Okay, so where will be this axis we have to show. So for that axis, let's call it as UU and VV axis. Okay, those are the principal axis. Position of principal axis we have to show. So suppose if this is the channel, uh, suppose this is our sorry, not channel, this is our angle. So for this particular angle, yeah. So our x-axis was like this, our y-axis was like this. Now it's been asked to us that what is the position of principal axis. Okay, so it is at 70.36 degree. So 70 means our angle, I'm just using different color just to make you understand. So this is another axis should be perpendicular to it. Okay, so this is your 70.36 degree. Okay, and let's call this as a UU and let's call it as VV. So that is a principal axis. Okay, now last part of this question, that is what is the value of principal moment of inertia. So that is the second point we have to find. What is the value of principal moment of inertia? Principal moment of inertia. So that is IUU is equal to IXX plus IYY by 2 plus Ixx minus Iyy by 2 sec 2 theta. So substitute all the values here. Ixx, what is the value? 1512500 plus 412500 divided by 2 plus 1512500 minus 412500. So these are our previous calculation values. Simply substitute it and you have to remember the formula. So here it is sec, not cos, sec 2 theta. So that is 140.72. So this answer we're getting it as 25,190. Okay, you please do use calculator and get the answer. So as per my notes, what answer I am having is this answer. Okay, so once we are done with this, then the last line, that is IVV. So IVV is equal to Ixx plus Iyy. So we have now all the calculation, all the values minus Iuu. So please see Ixx, what was the value Ixx? So that is Ixx was 1512 500 1512 500 plus Iyy was 412 500 and Iuu recent value 251905 251905.06. So just see how much answer you are getting. So IVV answer is 1673094. Okay, so this is a question. This was a question on unsymmetrical bending. And we were asked to calculate what is the position of principal axis and what is magnitude of the principal moment of inertia for this given particular angle. Okay, so hope you have understood this question, and in case of any doubt, please see the number scrolling on your screen. Okay, you can contact me through the through that WhatsApp number. Okay students, thanks for listening. Thank you.